Hello, hello all. Let's take a look today at Unit 5, Lesson 7, which covers addition and subtraction expressions. Now, this lesson sounds fancy, but it's actually pretty basic and straightforward. We've already taken a look at finding out a relationship or finding out a rule when we're looking at a table of numbers. And for today's lesson, what we're going to do is we're going to figure out what the rule is when we're given a set of information, and then we're going to use that rule to extend a table or to kind of fill in missing information in a table. Now, on the screen, I showed you a little table. It says right here, Jack, and then a set of numbers, and Javier, and a set of numbers. And we'll say that this is trading cards that they have. So we'll call these numbers trading cards. All right, so maybe they're football, baseball, basketball, Pokemon, who knows. So some trading cards. So we see that Jack has this number of trading cards, and Javier has this number of trading cards. Now, what I want to figure out is I want to figure out what the rule is between the amount of information that Jack has and the amount of trading cards that Javier has. So what I'm going to do is we'll call Jack, we'll call him K since that's the last name, or the last letter in his name, and we'll call Javier R since that's the last letter in his name. Now what I want to do is I want to figure out if Jack has this number of trading cards, how many then does Javier have? There's going to be a pattern between each set of information. There's going to be a pattern. So just like we did earlier in this unit, we're going to start step 1 by looking at the first set of information. So I see that if Jack has 17 trading cards, that Javier has 13. Now what I want to do is I want to figure out if I start with 17, how do I then get to 13? So I need to think to myself, if I start with 17, what can I do to 17 to get 13? How can I go from 17 to 13? So if I think about it, well, 17 is bigger, so I'm getting smaller. So 13 is getting smaller. In order to make a number smarter, you either subtract or you divide. So that's the only way we can make a number smaller. If we're getting bigger, we either add or multiply. But since we're getting smaller, we're going to either subtract or divide. So first, let's take a look at subtraction. What could I subtract from 17 to get 13? Well, if I think about it, I can subtract 4. I could subtract 4. If I have 17, if I subtract 4, I would end up with 13. How about division? What could I divide? Now, I'll tell you right now, even if you're still working on your division facts, you should know that 17, I would have to divide a decimal. Couldn't divide a whole number. 17, it can't be divided evenly by 13. I wouldn't get a whole number. So I'm probably not going to divide. It would be something like a decimal that we would end up with. So I'm probably not dividing, but I'm going to double check using my next set of information. So now that I've figured out that I'm probably going to subtract, I want to double check using the next set of information. So I'm going to take a look at the next set, and I'm going to apply my rule. If I have 20, if I subtract 4, does that give me 16? And I know that absolutely it does. If I have 20 and I subtract 4, I get 16. So it looks like this is my rule. So now I want to kind of put that into a numerical expression, which remember is a fancy way of saying a math problem with a letter in it. So what I want to do is I want to figure out if I start with Jack's number of cards, so whatever Jack has, what am I going to do to that number to get me Javier's number? So my rule is going to be R equals, Javier's number equals K minus 4. So Javier is going to equal whatever Jack has minus 4. This is our rule. Sounds fancy, but really it's not. Basically, what I'm saying is that whatever Jack has, if I subtract 4 from that, K minus 4, that gives me Javier. So for instance, if Jack has 25, I just erase the K and I put down 25. And then whatever Javier has would be 25 minus 4, which gives me 21. So it's really not that fancy, and it's really not that difficult to figure out how to apply these rules. It's actually really easy. So all we need to do now is to apply our rules to figure out and extend our table. So let's figure out, what if Jack had 40 cards? So for instance, if Jack had 40, what would then Javier's number of cards be? So remember, Javier, the number of cards that he has equals Jack's number of cards minus 4. So K stands for Jack. So if I substitute 40, I know that he's got 40. Then the number of cards that Javier has is simply 40 minus 4. What's 40 minus 4? That's 36. So Javier would have 36 playing cards. So that's really what we're doing in today's lesson. We're figuring out what that rule is, and we're just taking that rule and putting it into a number problem, a math problem. Let's take a look at another problem. All right, so same thing. I have Jack. He's going to equal K, the last letter in his name, and Javier is going to equal R. All right, so I want to figure out whatever my rule is. I want to figure out first, how do we get from Jack to Javier? So how do we get from the number of cards that Jack has to then the number of cards that Javier has? And the way that I start that, is that I want to first look at the first set of numbers. The first set of numbers, I start with 17, and I go to from 24. So I start with 17, and I then get to 24. First, I have to figure out if my numbers are getting bigger or if my numbers are getting smaller. Well, I see that my numbers are getting bigger, so I'm either going to add or multiply. That's the only way to make a number bigger, to either add or multiply. Now, I can figure out, I can add 7. That's how I can get from 17 to 24. Or I could multiply, again, I'd end up multiplying a decimal. It wouldn't be a whole number. So I probably won't be multiplying. We're probably going to add, but I can't know that that's true until I've checked my rule using another set of numbers. So now I want to check my rule using the next set of numbers. The reason we have to check our rule is because we're not 100% sure. We haven't verified it. We don't know for certain that that rule is going to work. So we want to check it to make sure that it's right. So I want to see if my rule of adding 7 is correct. So if I start with Jack, Jack has 20. If I add 7, do I end up with this number? And I see that yes, I do. So I can say that my rule is take whatever Jack has and then add 7, and that gives us the number of cards that Javier has. This math problem looks fancy, but if you say it out loud and kind of substitute what those letters mean, it's really not that hard. We're just saying that whatever Jack has, whatever the number of cards that he has, if you add 7 to that, you get the number that Javier has. So it's the same way of saying Jack plus 7 equals Javier. It's pretty much the same thing, but instead of saying Jack and Javier, we just use K and R. And then it gives us a much easier problem to work with. Now, I want to use this rule. I want to use this mathematical expression. And remember, an expression is a fancy way of saying math problem. To then figure out to extend my table and figure out something else. So we'll use 40 again. If Jack has 40, so if I say K plus 7 equals R, if Jack, which is K, if he has 40 cards, I'll erase the K and put 40 in. Whatever 40 plus 7 is will give me the number that Javier has. Well, that's pretty easy. 40 plus 7 is 47. So Javier is obviously going to have 47 cards. Now, when you guys are working on your your math problems in this lesson, always use a third set of numbers to just double check. So you always want to use a third set to just make sure that your rule is correct, because sometimes our rule, we might think it's correct, but we always want to use a third set. So Again, I can just double check. 25 plus 7 does equal 32. So that does verify that my rule is plus 7. But always when you guys are working on your math problems and when we work together in tomorrow's lesson, you'll see that we want to use that third set to verify. Now, this lesson is really easy because I'll give you the hint. You're only going to add or subtract. If you look at the title of this lesson, it's adding or subtracting. Whoops. It's adding or subtracting expressions. So we're obviously going to be adding or subtracting in this lesson. So the hint for your work in lesson 7 is that you will not be multiplying or dividing. You'll only be adding or subtracting. Hopefully that makes it a little easier for you. Go ahead and try your follow-up problems, and I'll see you in tomorrow's lesson for us to work together. Good luck, guys!